Panda, and now we are going to discuss about water supply and wastewater engineering in fundamentals. So some key points are there. Basic first, what is water supply system? So basic concept and necessity of water supply, the first point, and second point is the what is the water demand. Next is the per capita demand and variation in demand process. Factors affecting per capita demand, which is the most important topic in our concept. So methods of forecasting of population. These are the some key points that we will follow in this discussion. So next is what is water supply system? It is a branch of civil engineering system which provides how we will supply the water in various purposes like domestic, industrial, commercial purpose, public uses. So that is known as your water supply or water supply engineering. Next is what is the necessity of water supply? So first is for drinking and cooking purpose we are using the water, and for bathing and washing also we are using, for watering of lawns, gardens, all these things, and also we are providing in air conditioning system for strict washing, etc. So basically healthy water is required and adequate amount of water should be available for any type of location. So what is the quantity of water? Before going the calculation of quantity of water for any location, first we have to know what is the water demand for that particular city. So we have to go through the further basic concepts and what is the construction process over there, how many industries are over there, how many schools, hotels, all these things we have to taking into consideration. Then we will think and what is the present location according to the location which is the available area for the location, so that we can able to fulfill the demand of that location. So there are various types of demands. First is your domestic water demand, second is your commercial and industrial demand, third one is your demand for public uses, and fourth one is your fire demand. So what is domestic water demand? Domestic water demand basically includes our utensil washing, our bathing, our domestic water demand for average population or average standard people. It basically use up to 135 liter of water per day per head. But if the standard is very high, they can increase up to 350 liters, and it has been assumed or it has been standardized as per IS classification that 50 to 60% of total water consumption is due to only domestic purpose. Then these are the some concepts for an average person who is using the daily water demand. For drinking and cooking we are using 5 liter per day, and in bathing we are using about 55 liters per day, and in washing clothes we are using 20 liters, for utensil washing we are using 10 liters, and house washing we are using up to 10 liters. But in flushing and latrines it's basically maximum percentage of water is utilized, that is 30 liters per day, and the total is 135 liters per day per head. Next is the commercial and industrial demand for any location. It includes basically hotels, offices, hospitals, schools, shopping centers, etc. And it has been calculated that about 20 to 25% of water consumption is due to commercial and industrial purpose, and demand for public uses. In public uses, we just utilize the public utility, public parks, gardening, sprinkling on the roads, and it should not be exceed more than 5% of the water consumption. Next is your fire demand. So what is the fire demand? It is the fire breakdown. If what is the amount of water required to break down the fighting of the fire, that is known as the fire demand of any location. And there are many formulas to calculate the fire demand, where the Q is the quantity of water required in liter per minute, and P is known as the population of the town, that is in thousands. So according to Freeman formula, Q is the quantity of water required in liter, and its formula is total quantity of water required. Sorry. So this is the Freeman formula, and which for calculation formula is 1135.5. P by 10. P means here the population of any town in thousands plus 10. This is the Freeman formula, and according to Kuchling's formula, the Q means quantity of water is equal to 3182 root over of P, and according to National Board of Fire, calculation formula is Q equals to 4640 root over of P whole into 1 minus 0.01 root over of P. So these are some formulas which will come in your exam, and you have to just put the formula and get the answer. No derivation is required in this process. Next, we can go for per capita demand, which is a very most important thing in our exam also. It comes always. So it is the annual average amount of daily water required by one person by one day, and its formula. Before going the formula, we have to know what is Q and P. As usual, I have already told that Q is the total quantity of water required by a city per year in liters, and P is the population of that city. Then per capita demand equals to P divided by P into 365. You are using 365 because a year it has 365 days. Then variation in demand. So variation in demand, according to our we are not using the water throughout the day with a uniform set. So it varies. Due to the variation, we have categorized it in three types. First one is the second one is the daily variation, and third one is the hourly variation. So seasonal variation means in summer season we are using more water as compared to the winter season, because in drinking purpose, in bathing purpose, in washing purpose, for maintenance, and for cooler purpose also we use more water as compared to the winter season, because in cooler or all these things we don't need in winter season. So according to the seasonal variation, water varies or water demand varies. So according to daily variation, what happens? In daily variation, if you are considering the Sunday, then we are using that water from 8 a.m. But in working day, we are starting our water use from 6 a.m. So it also varies according to the day. In the morning or in the evening, we are using water more as compared to the middle of the day. That's why it also varies. In hourly variation also it varies. In holidays, it more required more, and in peak time there are some peak time within which we are not using the water for the whole 24 hours. We are using, there are some peak hour where we are using more and more water as compared to any other time. So next is the factors affecting per capita demand. What I have told already, Q equals to P by 365. We are calculating the per capita demand by this, using this formula. So what are the factors which affect our per capita demand? First one is your climatic condition. Climate condition also varies the water demand. How? If the climate is rainy season, we don't need for gardening purpose, for any strict washing purpose or fountaining purpose, we don't need more water. So according to the climate condition, water varies. But if in summer season we need more water, we consume more water, the consumer needs more water, that's why the water demand will increase. So this is called climatic condition. Or size of the city. If the size of the city is big, then more water is required for the maintenance purpose. If industries are large over there, if number of schools and industries are present over there, then we need more water for that purpose. But if the size of the city is more, then population is also less, and less organization over there, then less water consumption will be there. So it also affects the size of the city. Next is the habits of people. Habits of people also consume more or less water. I mean, habits of people means high standard people or educated or economically, if they are very sound, they use more water for maintenance purpose, for their decorative purpose. All these purpose they need more water. If they are low standard people, and they are not habituated with all these things and maintenance, then they will require more less water as compared to the economy. Next is the industries. If large number of industries are present in any country or any city, then they will require more water as compared to the other cities. Next is the cost of water. We all know if the cost will rise if any of any product, then we will use less as compared to our requirement. If the water cost is more, then the use of that product will be less. So if the cost will be more, then less people will, the quantity of water will be less used by the person. Next is the quality of water. If the quality of water is good, then more people will consume. As the quality of water is good and we can able to get it in easily, then we can use more water. Next is the pressure in the distribution system. If the pressure in the distribution is not uniform, then the people cannot able to use more water. It basically happens in multi-storied building, or if the pressure distribution is not maintaining in a proper manner, then they will not able to get the water properly, and the requirement cannot be fulfilled, or the persons cannot use more water. That will be affect the what per capita demand. Next is your system of supply, how the water is supplied. If the 24-hour system is there, all the 24 hours we can able to get the water, then we can use more and more. If the water supply system has some intermittent time period, for a certain period of time the water is coming, then the people will store that water for the whole day and they will use that only. Then the water use of water will be less. So these are the factors which affect the per capita demand. So these are the four methods of forecasting population. So before going for, I have previously told from the beginning that before going for the supply system of water, we have to know so what is the population, present population of the city, and we have to supply accordingly so that all the peoples can get able to get the water as per the domestic purpose, commercial purpose, industrial purpose, or whatever. So next, there are four methods, basically arithmetical increase method, geometrical increase method, incremental increase method, and decreasing rate method. By these four methods, we can able to calculate so what is the population is going to happen after 5 decades or 10 decades, whatever. So these are the first formula, arithmetical increase method. In this method, we can found in n years, means after 5 years or 10 years, we are considering it as n years. And here formula is Pn equals to P plus N into I, means P is the present population, means if I am in 2022, I am going to calculate 2025 population. So I have to consider the present population as 2022. So this is the present population, I yearly per decade increase in population. So what we are going to do here, we are just finding out before calculating for 2025, we should provide with 5 years population, so we can find out that how many difference they are providing. So that difference should be calculated and the average should be taken, and that average should be put here, and we can able to find out the population. When I will go for the numerical problem, then you can clear more. So this is the arithmetical mean method, where we just find out the difference of increase in population. We should take the average and put here, and n is the decade. N is the decade. And we can able to find out the Pn, means either in 2025 or 23 or 2030, whatever. Next is a geometrical increase method. It is better than the arithmetical increase method. Why? Because here we are just calculating the difference and are taking the average of that, then we are finding out the future population. But in geometrical increase method, we are going for the average percentage growth of last few decades is determined. Here we are calculating the percentage growth. We are not calculating only the number increase, just calculating the percentage growth of each decade. So thus the population of n decades will be Pn equals to P whole into 1 plus I by 100 to the power n. Here I is the percentage rate of increase in per decade. So this is better, this will give better result as compared to the arithmetical increase method. Next, we will go for the incremental increase method. Here in incremental increase method, this is the advanced version of both arithmetical mean method and geometrical mean method. So here what we are doing, the population of n decade, we are calculating by taking IA and IC. Sorry. Here IA and IC. So what is IA and what is IC? Here IA is average arithmetic increase and here IC is average incremental increase. So we are adding the both arithmetical increase and incremental increase. So it is the higher version of arithmetical mean method and geometrical mean method. Whatever result we are getting in arithmetical mean method and geometrical mean method, as compared to that two method, we are getting better result in incremental increase method. So next is your decreasing rate method. In this method, the average decrease in the percentage increased, and then that we have to find out that average decrease in the percentage increase. First we have to find out of each and every year, then we can subtract it that with the latest increase in each decade, then we will get the final result. So next session we will try to discuss about these four methods, and we have to calculate a numerical so that we can able to clear very nicely, so that whatever doubts you can have, I can clear you. Thank you.